Hello students, welcome to the class. In today's class, I will start solving numericals on first chapter of class 11, that is electric charge and fields. And from this chapter, I will solve many questions. So keep watching. The first question is, two small spheres, each having the charge plus q are suspended by insulating threads of length L from a hook. This arrangement is taken in a space where there is no gravitational effect, and the angle between the two suspensions and the tension in each thread, you have to tell out of these four options which one is correct. Okay, let's solve it. See, the question is, two small spheres, each having the charge plus q are suspended by an insulating thread. Okay, by an insulating thread. Let's say this is the rigid support, and from that support, let's say there is a hook. Let's say there is a hook, and from this hook, I am suspending two spherical balls having charge plus q. So, what will happen if this is the thread and you suspend two balls having charge plus q, then there will be repulsion between these two balls, right? If there is a suspension, if you suspend two balls and these two balls are at the same position, then they will not be at the same position. They will repel until there is no force on these two balls. There is no means if the resultant force becomes zero. So if there is two balls, one ball will go this way and one ball will go this way, right? So if there is two balls, one ball will come this way and one ball will come this way because of their mutual interaction. Mutual interaction means, I mean to say, because of their repulsion. This will repel this and this will repel this. So these two balls will go this way, right? But look at the question. There's saying that this arrangement is taken in a space where there is no gravitational effect. So if there is no any gravitational effect, then this component is zero, right? Because if there is no gravitational effect, then the weight of the ball will be zero. And if the weight of the ball is zero, and so if there is no vertical component downwards, then these two balls will go and will come here. This ball will come here, and this ball will go and will come here. And this distance between the two balls, I think you understood why these two balls are going this here and here. These two balls are here and here because there is no gravitational effect. So now see the length of suspension where was capital L, right? So this length will be capital L and this length will be capital L from here. So the total length between the two balls will be capital 2L, right? So if the capital length between the two balls is capital 2 capital L, then of course the force will be 1 by 4 pi epsilon naught q1 q2, both have charge plus q, so it will be q square divided by the length square, that is 2L whole square. And what is the angle between these two suspensions? Of course, this angle between these two suspensions is 180 degree. So the option, which option is correct? So this option is correct, option A, right? 180 degree and 1 by 4 pi epsilon naught q square by 12 whole square. So option A is correct. Okay. Okay. Let's move to the next question. The second question is, two equal point charges, each of 3 microcoulomb, are separated by a certain distance in meters. If they are located at plus I plus j plus k cap and minus 2I plus 4j plus k cap, then electrostatic force between them is, out of this out of these four options, one is correct. So you have to tell which one is correct. Okay, let's do it. 2 point charges, each of 3 microcoulomb, are separated by certain distance, and you are given their locations. Let's say for the first charge, the location is R1, and R1 is plus I plus j plus k. And for the second one, R2, let's say this location is R2, so it will be minus 2I plus 4j plus k. So of course you can find what is the displacement between these two charges. So the displacement between the two charges will be R1 minus R2, and it will be I minus 2I, that is 3I, and plus J minus 4 plus J minus 4J, it will be minus 3J, and plus K minus K cancel, nothing. But let's say that the magnitude of the distance will be R1 minus R2. It will be nothing but simply 3 square plus minus 3 square, that is under root 18, right? 9 plus 9, 18. Okay. Now what we need? We need we need to find the electrostatic force between them. Of course, the question is simple now. F is equals to 1 by 4 pi epsilon naught and 3 microcoulomb each. So it will be 3 into 10 to the power minus 6 coulomb into 3 into 10 to the power minus 6 coulomb divided by the distance square. Distance square will be nothing but 80, right? R equal to root 18, so R square is equals to only 80. So it will be 1 by 4 pi epsilon, it is 9 into 10 to the power 9, and it will be 3 into 3, 9, 10 to the power minus 12, it is 18. So if you cancel 9 by 18, it is 2, 2, 9, it will be 4.5, right? Then answer is 4.5 into 10 to the power minus 3, right? 12 minus 9 is 3 and minus sign, so it will be 4.5 10 to the power minus 3 Newton. So which option is correct? Option C is correct. Okay. Okay. Let's move to the next question. That is question number 3. Okay. The question number 3 is 3 charges plus Q, plus 2Q and plus 4Q are connected by strings as shown in this figure. What is the ratio of tension in the string AB and BC? And out of these 4 options, one is correct, and you have to tell which one is correct. Okay. So the tension in the string AB will be due to the repulsion between A and B and the repulsion between A and C. Due to that, there will be the tension in this string. Let's say the tension TAB is divided by TBC. There is the ratio of TAB TBC is nothing but the force of repulsion between F AB, this force repulsion between A and B, plus the repulsion between A and C, and TBC, that is the tension in the string BC, is due to the force of repulsion between B and C plus C and A, repulsion between C and A. So it will be FAC or FCA, the same thing. The magnitude is same, you know, the direction is just different. So it will be nothing but what will be FAB? It will be 1 by 4 pi epsilon naught. Let me take common 1 by 4 pi epsilon for both the forces, and this will be 1 by 4 pi epsilon naught plus Q plus 2Q divided by the length square, that is 2Q square by L square plus, and charge at A is plus Q and at C is 4Q. So it will be 4Q square by L square, and same thing. If I take 1 by 4 pi epsilon naught common, then B and C, between B and C it is 8Q square by L square, because at B 2Q and at C 4Q, and at A plus Q and at C 4Q, it is again 4Q square by L square. Now what it will be? This thing cancel out, and if you take Q square by L square common here and Q square by L square common here, then it will be Q square by L square also cancel out. Then simply it will be 2 plus 4 is 6, and here will be 8 plus 4 is 12, right? Because Q square by L square, if you take common, it will be cancel out. Then 2 plus 4 is 6, 8 plus 4 is 12, then it will be nothing but 1:2. Which option is correct then? Option A is correct. Okay. Okay, let's move to the next question. Okay, the question number 4 is 2 charges plus Q and minus 3Q are placed fixed on x-axis separated by a distance d. Where should a third charge plus 2Q be placed such that it will not experience any force? Okay, so let's say this is x-axis. This is the x-axis, and on the x-axis, let's say here plus Q charge is placed fixed, and here minus 3Q charge is placed fixed, and the distance between them is d. And you have to say where you should put a third charge plus 2Q such that it will not experience any force. So let's say we don't know anything, where we will put that this plus q charge. Okay, so let's say I will put this plus 2q charge at a distance x from this plus q charge. Let's say I will put this plus 2q charge at a distance x from plus q. Okay, let's say we will put at a distance x. Now then what will be force experienced by plus 2q due to plus q? Let's say this is f1, then it will be nothing but 1 by 4 pi epsilon naught plus q and plus 2q. It will be 2q square by the distance. Distance is x. We assume that the distance is x from okay. We have assumed it from plus q. Okay, sorry, from plus q. So it will be 1 by 4 pi epsilon naught 2q square by x square. And force experienced by same charge plus 2q due to minus 3q charge, it will be, let's say it is f2, and it will be 1 by 4 pi epsilon naught, and it will be 2q square divided by x plus d whole square, because this minus 3q charge is at a distance d from the plus q charge. Now you may ask why it is x plus d. Why I should put the charge in this direction? Why cannot I put this charge in between these two? What will happen if I put this charge in between these two? First of all, you cannot put this plus 2q charge in between plus q and minus 3q. Why? Because if you put the charge plus 2q anywhere on this line between plus q and minus 3q, then let's say I put the charge here. Let's say I put the charge plus 2q here, plus 2q here. Then what will happen? Plus q will repel this plus 2q charge. That is, it will experience plus 2q charge will experience a force along x direction due to this plus q charge, and minus 3q will attract this plus 2q charge, right? Then due to minus 3q also plus 2q will experience a force along x direction. Then the net force on the plus 2q charge will never be zero if it is in between plus q and minus 3q. So it should be on either on this side or that side. Okay, so I assumed the plus q charge is at a distance x. So of course it is at a distance x plus d from minus 3q. It is not d minus x. Okay. So let me find what will be the value. So now, if the force experienced by plus 2q due to plus 2q is this, and due to plus q is this, and due to minus 3q is this, then if the charge plus 2q is experiencing no force, then the resultant force of F1 and F2 should be zero. That is, F1 and F2 should be of the same magnitude but in different directions. Okay, and so these are the magnitude of the force F1 and F2. Then according to question, this F1 should be equal to F2. That is 1 by 4 pi epsilon naught 2q square by x square should be equal to 1 by 4 pi epsilon naught 2q square by x plus d whole square. Okay, then this thing will cancel out. Plus 2q plus 2 plus 2 plus 2 will go on. Okay, I'm sorry, this is not plus 2, it is minus 3, right? So it will be 6. 2 into 3, right? So it will be 6, because this is experiencing plus 2 is experiencing force due to minus 3. So the magnitude of the charge will be 3. So it will be 6. So if it is 6 here, then 2, 6, then it will be 3. Okay, right? It is 3. Then q square 1. Then it will be 1 by x square equal to 3 by x plus d whole square. Okay, then what will be x square plus 2xd plus d square equal to 3x square, right? Then if I put this thing on that side, it will be 2x square, 3x square minus x square is 2x square minus 2xd minus d square equal to 0. Okay, so it will be, now what will be the value of x? Now x will be minus b, that is 2x, sorry 2d, it will be 2d plus minus b square, b square is 4d square minus 4ac, 4a is 2, c is minus 1, so it will be minus d square, so it will be this thing divided by 2a. Okay, so it will be if you take 2 common, then it will be d plus minus, see, it will be 4 plus 8, it will be 12 d square, right? So it will be 12 d square, 12, but I am taking 2 common, then it will be, if I take 4 outside, then it will be outside the root, then it will be 2, 2 to cancel, then it will be only 2, and it will be d square plus 2d square, it is under root 3d square, so it will be under root 3d. So the correct option is x can be either d plus root 3d by 2, or it has to be d minus root 3d by 2. But see, d minus something is not possible because the charge cannot be in between this plus q and minus 3q. So the correct option is this one, d plus root 3d by 2. I think it was option okay, I don't know what was the option, I don't know, but the correct option is d plus root 3d by 2. Okay, so the question number 5 is two positive ions each carrying charge plus q are separated by a distance d. If F is the force of repulsion between the two ions, the number of electrons missing from each ion will be, out of these 4 options, one is correct. So you have to find which one is correct. See, two positive ions, they have charge plus q and the force of repulsion is F. So we know the expression for F. F is 1 by 4 pi epsilon naught. Both have charge plus q, so it will be q square divided by their distance. Distance is d, so it will be d square. So now we can simply find what is q square. Q square will be simply 4 pi epsilon naught f d square, right? Now the q will be under root 4 pi epsilon naught f d square. Okay, but one thing you know, right, that charge is quantized in a body. Charge is quantized in a body, that is, the charge should be integer multiple of E, that is the charge of electron. So we know Q should be equal to NE, integral multiple of the charge of E. I don't know how many electrons are missing, but let's say n number of electrons are missing. If n number of electrons are missing from a body, then it will acquire a charge Ne, right? Positive Ne if n number of electrons are missing. Let's say n number of electrons are missing, then total charge should be Ne, right? Now if you place Q equal to Ne, then Ne equal to will be under root 4 pi epsilon naught f d square, or n will be 4 pi epsilon naught f d square divided by e square. If you take it inside the root, that will be e square. So which option is correct? Option C is correct, right? F d square by e square. Okay. Okay. That's it for today, and meet you in the next class. Okay. Bye.